this class, we discuss with circular permutations. What is a circular permutation? If things are arranged along a line or in a row, that is called a linear permutation. But if the things have been arranged around a circle, then it is a circular permutation. So permutation along a line is a linear permutation. A permutation around a circle is called a circular permutation. Well, is it necessary to have a separate heading, separate discussion for these circular permutations? That is the general question which is generally faced by an ordinary student. If 4 persons are there arranged in a row, say A, B, C, D, then we take the arrangement as either A, B, C, D or D, C, B, A. But if those 4 persons are arranged around a circle, then it can be read as A, B, C, D, B, C, D, A, C, D, A, B, like that. Different things may occur. So it is sure to have a separate heading and a separate discussion for circular permutations. Well, what is the way to arrange a given number of objects around a circle? Suppose n things have been given. They are supposed to be arranged around a circle, say like this. Let us first imagine this circle is framed up of a wire. A ring-like arrangement is there. You choose a particular person and let him be sit at one place. One person in one place can be done in one way. A particular person, rather thing, is arranged here, this position. After getting this arranged, you just cut this wire, then it will be stretched. It is then considered as a line. The remaining n-1 persons or things can be arranged in n-1 factorial in that line. After getting arranged all of those things again, you join this once again. The circle is now completed and the total number of arrangements you could have formed is n-1 factorial. Therefore, the number of arrangements of n things around a circle is, here we observe 2 types of answers. One answer is n-1 factorial if the direction of arrangements is specified. And one more thing, n-1 factorial by 2 otherwise. In the sense, the direction of arrangements is not specified. If we are interested to find the arrangements in both the directions and if they look different and if you want to consider them, if you want to pertain about the direction, the answer is n-1 factorial. Otherwise, that is, if it is not necessary to pertain about the direction, then the answer will be n-1 factorial by 2. If 10 persons are there, they are to be arranged around a circle, it can be done in 9 factorial. That is n-1 factorial, that is 10-1 factorial, that is 9 factorial. If 10 flowers are given, say 10 roses, they are to be arranged around a circle. If you observe the they are to be arranged around a circle, that it means so suppose you are supposed to frame a garland about those 10 flowers. 10 flowers are given. You are supposed to frame a garland. How many ways you can construct a garland? That is the question. After getting them arranged around a circle, that is, after the garland has been formed, if you observe the roses in this direction or in this direction, as you like, everywhere you will see rose, 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 rose flower. So it is not necessary to be pertinent about the direction. You need not consider the direction. In such a case, the answer is n minus 1 factorial by 2. Yes. Let us now observe the difficulties and easy factors in this concept. In the earlier problems, every student is aware of this simple concept that if 15 persons are arranged around a circle, they can be done in 14 factorial. If 15 flowers are there, then the number of garlands that can be made is 14 factorial by 2. If 20 diamonds or some special stones are given, some 20 special stones, precious stones, special stones are given, and you are supposed to frame a necklace, how many ways you can do that? 20 minus 1, that is 19 factorial by 2. Well, let me ask you one more question. If 10 girls are there, how many ways you can arrange around a circle? 9 factorial. 10 minus 1, that is 9 factorial. Let me change the question. How many ways can 10 girls be arranged around a circle to dance around a circle? That is the new question. What is this new feature here? While they are dancing around a circle, you cannot fix the direction of observation. If you observe the girls in this direction or in this direction, it might be confusing to be fixed about one particular direction, and it's not possible. In such a case, the direction of arrangements is not specified in that arrangement. So we see and say that the number of arrangements of 10 girls to dance around a circle is 9 factorial by 2. That is 10 minus 1 factorial by 2, only because the direction of arrangements is not specified. Not only that, suppose some 15 persons are there. How many ways can you arrange them around a circle? 14 factorial. Now let me change the question. How many ways can you arrange 15 men around a revolving round table? A revolving round table. It is not stationary. It has been moving. So you cannot be specified about the direction. You cannot be particular about one particular direction. In that case, also the number of circular permutations is how many? 15 men, then 14 factorial by 2. If 20 men are there, then it is 19 factorial by 2. By observing all these cases, we can fix one particular thing in our mind. Suppose in a problem, a circular arrangement is being asked. You think of the circle in which the things are going to be arranged. Is it a fixed circle or the circle is under movement? You observe. Garland, it is not a fixed circle, it is under movement, so you cannot be pertained about the direction. Hence we say by 2, that is n minus 1 factorial by 2. Well, let me make the things very clear once again. Let us observe these two problems. 10 flowers are given. How many ways can you make a garland? 10 minus 1, 9 factorial by 2. Well, let me change the sentence. I give you 10 flowers and I ask you to decorate the circle drawn on the wall with those 10 flowers. How many ways can you arrange those 10 flowers around this circle? Fixed circle. It is not 9 factorial by 2. It is 9 factorial only. 10 flowers are there. 10 minus 1 factorial because it is a fixed circle. You can very clearly observe the arrangement in both the directions. In this direction the flowers are beautiful, in this direction the flowers are special and excellent. Like that you can throw comments. Why? Because you are able to observe the arrangement in both the directions. That is, the direction of arrangements can be specified there. Therefore, in such a case, the answer will be 10 minus 1, that is 9 factorial only. I think the things are clear. It is a fixed circle. That is why it is 9 factorial. Well, let me bring one more comparison into your notice. 20 diamonds are there. They are given. You are supposed to frame a necklace. How many ways can you frame a necklace with 20 diamonds? 19 factorial by 2. Necklace means it's not a fixed circle, it is under movement. So the direction of arrangement is not specified there. So it is 19 factorial. You observe the case. There is a person, a strong devotee of the Lord Venkateshwara in India. That particular person has taken 20 diamonds and have put those 20 diamonds in a small bag along with a small letter. You please affix these 20 diamonds around the crown of the Lord Venkateshwara. He has written that sentence. The authorities of the temple have seen the letter and observed the diamonds, and they decided to fulfill his desire. In how many ways these 20 diamonds be affixed around a crown? Crown means it is a fixed circle. It will not be the place where the diamonds are being arranged is a circle, and it is a fixed circle because it will be kept fixed in a fixed manner. Therefore, the number of ways of affixing those diamonds around the crown is just nothing but 19 factorial only, because it is a fixed circle. Like that, we observe the things to be arranged around a circle. There are some special cases. We now observe some special cases in these circular permutations. Let us observe this new problem. There are 6 boys and 4 girls. 6 boys and 4 girls. Altogether 10 in number. How many ways can we arrange them in a circle? 10 minus 1, that is 9 factorial. Usual answer. No change in it. No question of any variety. There has been a twist here. What is that twist? How many ways can 6 boys and 4 girls be arranged around a circle such that all the 4 girls come together? Rather, they sit together. That is the special twist here. Let us now attend to the problem. Here, 2 pieces of work are there. Number 1, there are 4 girls that to be treated special. You call all of them and put them in a box. That is the first piece of work. Oh, these are girls. 4 girls. How can you make those 4 girls in a block? It can be done in 4 factorial ways. The second piece of work. Along with this block plus what are remaining? 6 boys. 6 boys. How many are they in number? 6 plus 1, 7. 7 persons. 7 persons can be arranged around a circle. How many ways? 7 minus 1 factorial, that is 6 factorial. This is the first piece of work. This is the second piece of work. As a total, the total number of ways is 4 factorial into 6 factorial. This is the number of ways of arranging 4 boys and 6 girls, 6 boys and 4 girls in a circle such that all the 4 girls sit together. By keeping this in mind, you can answer any such question immediately. How many ways can 10 boys and 6 girls be arranged in a row such that all the 6 girls sit together? In a circle, they sit together. 10 factorial into 6 factorial. Another problem. There are 8 boys and 5 girls, altogether 13. They are to be arranged around a circle such that all the 5 girls sit together. What is the answer? 8 factorial into 5 factorial. Of course, these considerations will reveal the answer like that. 8 factorial into 5 factorial. Well, let us now observe another such case with a different twist. As before, there are 6 boys and 4 girls. Here the question is, how many ways can 6 boys and 4 girls be arranged around a circle such that no 2 of the 4 girls sit together? That is the condition here. That is the condition here. Well, let us attend to the problem. 6 boys are there, 4 girls are there. There is a condition on these persons and there is no condition for these boys. Let us first arrange all the 6 boys first around the circle. First boy, second boy, third boy, fourth boy, fifth boy, sixth boy. 6 boys are there. Then there are 4 girls. What is the condition given for those girls? No 2 of them should come together. So they must be arranged in the gaps between the boys which were already arranged. How many gaps are there? 1, 2, 3, 4, 5, 6. 6 gaps are there, 4 girls are there. Come on, what is the answer? Can you use circular permutations formula? It's not possible. Here the thing that must be kept in mind is, as and when you fix the places for the things to be arranged, these permutations must not be considered circular. They are linear. What I mean to say is, these 4 girls, what are the proper places for these girls to be arranged? These are the particular places. These are the fixed specified places. In such a case, we should consider those arrangements as linear only. Well, there are 6 possible places and 4 girls there. How many ways can you arrange them? 6p4. So arrangement of boys, 6 boys around a circle, 6 minus 1 factorial. Arrangement of girls, 4 boys, 6 places, 6p4. So total answer in this case is 5 factorial into 6p4. This is the answer. This is the total answer. So, while considering circular permutations and while arrange the things at a specified places, you're not supposed to consider those arrangements as circular permutations, but you are to take them as linear. And with our usual thinking, they are to be answered like this. So these are the things that must be kept in mind while answering the questions regarding circular permutations. Now we turn our head towards a new topic in permutations, that is permutations in which repetitions are allowed. Permutations in which repetitions occur. This is a special heading. Well, let us observe the things by means of some examples. Suppose I have 4 sweets with me and there are 10 children before me. The actual question is, how many ways can these 4 sweets be distributed along these 10 children such that one child is entitled to get any number of sweets? If I like a particular child very much, then I can give all the 4 sweets to that particular child only. No problem. This is the way. In how many ways can this be done? For such problems, in textbook some formula, say n power r will be given. And an average student thinks that the formula is n power r. In general, n is greater and r is smaller. Oh, for these answers, smaller number comes to the exponential place. Like that he thinks of. I'm sorry to say that it is wrong way of thinking. Then what should we think for this one? In what way should we think? Let us see. How many sweets are there? 4. How many children are there? 10. What are the things undergoing distribution here? Sweets or children? Are you distributing sweets or are you distributing children? We are distributing the sweets, not the children. Well, start the explanation with that only. First sweet. How many ways can you give? There are 10 children, 10 ways. Second sweet, 10 ways. Third sweet, 10 ways. Fourth sweet, 10 ways. Altogether, 10 into 10 into 10 into 10. How many ways? 10 power 4 ways. 10 power 4 ways. Suppose I reverse these two numbers. I have 10 sweets with me and there are 4 children before me. In this case also the same answer 10 power 4 occurs? No. What is the number of sweets with you? 10. What is the number of children before you? 4. Are you distributing sweets or children? Sweets. Come on, start with the explanation. First sweet, 4 ways. Second sweet, 4 ways. Third, 4 ways. Fourth sweet, 4 ways. Like that, 10th sweet, also 4 ways. In that case, the answer will then become 4 into 4 into 4 into etc. 4. How many times? 10 times. In that case, the answer is 4 power 10. You please observe these two answers. So, you please don't think of the blunt method to remember. You please think of the way to follow. What is the number of things undergoing distribution? That comes to the exponential place. The place of the exponent. Here 4 sweets are there, so 10 power 4. Here 10 sweets are there, 4 power 10. Let me make it clear by means of another example. I am given the authority of allocating some scholarships to the students in my college. I have the authority to distribute 6 types of scholarships to the students, and I found only 3 students eligible in that particular class to which the scholarships can be allocated or awarded. Of course, each student is eligible to get any number of scholarships. In how many ways can I distribute the scholarships? I have 6 scholarships with me and there are 3 students I found eligible. What is the number of ways? Is it 6 cube or 3 power 6? Am I distributing scholarships or children? I am distributing scholarships. So the answer is 3 power 6 or 6 cube. Start with the explanation. First scholarship, 3 ways. Second, 3 ways. Third, 3 ways. Fourth one, 3 ways. Like that. 3 into 3 into 3 into 3 into 3. How many times? 6 times. So it is 3 power 6. Observe the answer. What is the number in the exponent? 6. That is the number of things undergoing distribution. Let me give you one more example. I have 6 letters with me to be posted. I have gone to the main post office. There are 10 post boxes before me. They are inviting me. I would like to post these letters, 6 letters in the 10 post boxes. Any number of letters can be posted in a box. What is the number of ways? It is 10 power 6 or 6 power 10. What are the things undergoing arrangements? Letters. So 6 comes into the exponential part, that is 10 power 6. Why? First letter can be posted in 10 ways. Second letter can be posted in 10 ways. In any post box I can post it. Third letter 10 ways. Fourth letter 10 ways. Like that. Sixth letter also 10 ways. So the total number of ways in which the letters can be posted is 10 into 10 into 10 into 10 into 6 times, that is 10 power 6. One more example. A person has 8 rings. 8 rings. He likes to wear them to to the 4 fingers, F-O-U-R 4, of his right hand, how many ways can he wear those rings such that any number of rings can be worn to your finger? Come on, what is the things? What is the number of things undergoing distribution? Rings or fingers? Rings. Are you arranging rings? Or if the rings are suspended, are you introducing the fingers? No, the rings have been arranged. So, first ring, 4 ways, second ring, 4 ways, third ring, 4 ways, like that. What is the answer? 4 power 8. In this way, we think of solving the problems in which the number of things is being repeated. Yes. Let us see some more examples in which repetitions occur. Let us now observe this question. The question before us is, what is the number of 5-digit numbers that can be formed by using 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, in which at least one of the digits repeated? At least one of the digits repeated. That is the question. What is the question? 0, 1, 2, 3, 4 up to 9. What is the total number of digits given? 10 digits are given. Using all these 10 digits, you are supposed to form 5-digit numbers. 5-digit numbers. In these 5-digit numbers, at least one of the digits must be repeated, he is asking us. So in this question, so many cases may arise. 1 digit might be repeated, 2 digits might be repeated, 3 digits might be repeated, 4 might be repeated, 5 may be repeated. And it is time taking to consider all those 5 cases. So to avoid that, we proceed in this way. That is the old idea, very good idea. That is total minus negation. Is it a formula? Is it a principle? No, it is an idea, just an idea. With this idea, we will be able to frame the answer very easily. Well, what is the word total means? 5-digit numbers are required. These are the digits given. With repetitions or without repetitions are totally. What is the total number of things? What is the total number of arrangements? That is 5-digit numbers. Let us see. Total. To frame a 5-digit number means we are supposed to fill 5 places. In the first place, how many ways can you fill? In the first place, there must be a non-zero digit. Altogether 10 digits are given. How many non-zero digits are there? 9 non-zero digits are there. With any one of those 9 non-zero digits, you can place here in how many ways? 9 ways. Well, in this place, how many ways can you fill up? 10 ways. Here, 10 ways. Here, 10 ways. Here, 10 ways. Why 10? Repetitions are allowed. We are not discussing at all about repetitions or without repetitions. Total number of arrangements we like to gather. What is the total number of these numbers? 9 into 10 power 4 minus negation. Negation is to be considered. To what concept the negation is to be considered? To the required. What is required here? In the problem, at least one of the digits is repeated. What is its negation? None of the digits are repeated. None of the digits is repeated. So without repetitions, how many arrangements will be there? You think of it in that corner. Let us do that. The first place can be filled in how many ways? This must be a non-zero digit. It can be done in 9 ways. It can be filled in 9 ways. Well, still, How many places are remained? 4 places are remained. How many digits are remained? 9 or 8? Total number of digits given 10. Only one digit is being used here. So remaining number of digits is 9. Using those 9 digits, you are supposed to fill these 4 places. How many ways you can fill them up? 9p4 ways. So in this case the answer is 9 into 9p4. Therefore the total answer is 9 into 10 power 4 minus 9 into 9p4 is the required answer. That is the number of 5-digit numbers in which at least one digit is repeated. That is the question. So we have made use of the concept total minus negation. That is a beautiful idea. Whenever number of cases to be considered is large, we proceed in this way. That is total minus negation. This is the answer for this question. Now, let me change this question once again. This question is, how many 5-digit numbers are formed? Now I am changing the question. How many 5-digit telephone numbers can be formed using the digits 0, 1, 2, 3, 4, 5, 6, etc.? If that is the case, if that is the question, what will be the change in our idea? What is the change in that answer? Is there any change or not? First of all, let us see. What is the question? What are the digits given first of all? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the digits, and we are supposed to form 5-digit telephone numbers, not 5-digit numbers. We require 5-digit telephone numbers. So, to form a telephone number, the telephone department authorities do not mind at all to put 0 in the first place. They have no objection at all. They have no any such sentiment. They can use 0 in the beginning also. It can be called a 5-digit telephone number, no problem at all. So, what is the total number of 5-digit telephone numbers? This is 10 ways, this is 10 ways, this is 10 ways, this is 10 ways, and this is also 10 ways. The total is 10 power 5. Again, we have missed to recollect the idea. What is the question here? What is the number of 5-digit telephone numbers with at least one of the digits repeated? That condition is again there in the new question also. What is the main question? How many 5-digit telephone numbers can be formed in which at least one of the digits is repeated? Well, we shall now use the same old idea, that is total minus negation. Total means the total number of telephone numbers is 10 power 5 minus negation. Negation to what? Negation to the requirement. What is the requirement? At least one of the digits is repeated is the requirement. What is its negation? None of the digits is repeated. That is, we want to have the telephone numbers with no repetition at all. How many ways can you frame? 1, 2, 3, 4, 5. Is there any special condition on the first place? Is it necessary to take any precautionary measure? Is there any sin if 0 is entered there? No such sin is there. No objection is there. All those 5 places can be filled by the 10 digits available in how many ways? 10p5 ways. So the answer is, for this question, the answer is 10 power 5 minus 10p5. 10 power 5 minus 10p5 is the answer in this question. Like this. This is a beautiful example also. This is also a beautiful example in the number of arrangements in which repetitions occur.